Welcome guys to our channel Mathematics by Fanat. Let us today see the introduction of chapter 10 Circles. A circle. What is a circle? A circle is a collection of all points in a plane which are at a constant distance from a fixed point. Let us take this as a circle and let point O be the center. Center is the point from where the circle is drawn using a compass or something. It has an equidistant. So we have seen circle. Circle is the collection of all points in a plane. Radius. Radius is defined as a constant distance from a fixed point, the center. This can be named as R. We have seen. What is diameter? Diameter is a line passing between the center and touching the both parts of a circle. That is circumference. Circumference is the perimeter of a circle. If we take a square, we call it perimeter. Similarly, for a circle, the boundary is the circumference. Now, let us see lines and circles. Let this be O, center of the circle. A chord is a line that passes between 2 points in a circle but does not pass through center. If that passes to the center, then it's called a diameter. So, the largest or the longest chord is our diameter. Diameter is 2 times that of radius. Okay, what is a tangent? Tangent is a line to a circle that intersects the circle at only a single point. So this point is the tangent of the circle. It touches the circle at only one point, and that point is called the point of contact. Here in this diagram, R is the point of contact. What is a secant? If a line passes through a circle directly at 2 points and does not cross anywhere, like it touches 2 points, it is called a secant. This is a non-intersecting line. This line hasn't touched the circle. This is a tangent touching the circle at a single point. And this is secant as it touches the circle at 2 points and it passes through the circle. Now let us see theorem 10.1. Theorem 10.1 says that the tangent at any point of a circle is perpendicular to the radius through the point of contact. Let us see what does it mean. Let's draw a circle. Let O be the center, and they have said that the tangent at any point of a circle is perpendicular to the radius through the point of contact. Let's draw a tangent. Tangent AB. And the point of contact be P. And we know OP is our radius. They have told that now OP is perpendicular to AB. In general, in geometry, the shortest distance from a point to a line is perpendicular. This is a basic fact in geometry. This becomes a longer distance, whereas the shortest distance creates an angle of 90 degrees to the line. So taking this as a base, we know OP is the radius. Let us draw another line which has a point on the line AB, Q. Let us join them and make it as OQ. The point intersecting the circumference be R. We know OP is R. OR is also R, that is radius of the circle. We also know that OQ is definitely OR plus RQ. That means OQ is greater than OR. We also know that OP is equal to OR as it is equal to radius. So we can substitute it as OQ is more than OP, which indirectly means that OP is the shortest distance between the point and the line, which gives us OP is perpendicular to AB. So the theorem is true. That tangent at any point of a circle is perpendicular to the radius to the point of a contact. We should remember this theorem because we use it many times in our problems. Now coming to points and circles, we'll see 3 cases. Case 1. If there is a point inside the circle, there will be no tangent passing through that point, because let us see the case first. There is no tangent to a circle passing through the point lying inside the circle. See, in this example, point P has many lines passing through them, but there will be no tangent passing through the point P. This is the first case. Second case, there is one and only one tangent to a circle passing through a point lying on the circle. This is a circle with center O and line AB, that is tangent AB, intersecting circle at point P. They said that at this point P there can be only one tangent. Similarly, we can have another tangent here, here, here. We can have infinitely many tangents, but they all make a point of contact at only one places. That is the meaning of this sentence. Okay. Now let us see case 3. Case 3. There are exactly 2 tangents to a circle through a point lying outside the circle. They said that from a point P, let us take this point as P. There are only 2 tangents to a circle passing through that point. If we draw some other line like from P, they cannot be tangent. They can be a secant line or a chord or something like that, but they cannot be tangent. This is the meaning of this third case. Now let us see theorem 10.2. The lengths of tangent drawn from an external point to a circle are equal. They are given that from a point P, we have drawn 2 tangents to the circle. Let the point touching the circle be R and Q. We will draw the radius over there. From theorem 1, we know angle Q and angle R are 90 degree. Let's draw a common line OP. We can prove this using congruent triangles. We know that we have 2 triangles, that is triangle OQP and the triangle ORP. OP is equal to OP, that is our common side. OQ is equal to OR, that is our radius. And we also know that using theorem 10.1, angle OQP is equal to angle ORP, that is 90 degree. So by RHS property, triangle OQP is congruent to triangle ORP. By using CPCT, that is congruent parts of congruent triangle, we know that PQ is equal to PR. This can also be proved in another method using Pythagoras theorem. Let us solve that also. We know that both triangles OPR and OPQ are right angle triangles. So our radius is the height and PQ is the base and our hypotenuse is OP. So let us see in triangle OQP and triangle ORP. Here by Pythagoras theorem, hypotenuse square is equal to side square plus base square, right? So substituting them in triangle OQP, OP square is equal to OQ square plus PQ square. In triangle ORP, OP square is equal to OR square plus PR square. We also know that OR is equal to OQ, that is R. Since OP square and OP square is common, we can equate both these equations. OQ square plus PQ square is equal to OR square plus PR square. We also know that OR and OQ are equal, so we can cancel them. I'll write in a separate step. OQ square plus PQ square is equal to OQ square plus PR square. We can cancel them out, which gives us PQ square is equal to PR square. That is PQ is equal to PR. So if you get a question stating prove the theorem 10.2, we can do it in 2 ways. You can follow which one is easier. This one is by using congruent path of congruent triangle property, and the other one is using Pythagoras theorem. So in our further videos, we'll learn to solve exercises of this chapter. Thank you. Happy learning.